Alright, welcome back. So right now we can look at how a experimental probability can be used from survey data. And this is useful in that ultimately it can give us a likelihood within a group of a preference or a result occurring. So if you look at the question, we have a school canteen has tracked the lunch of 40 different students. And basically we have all of the chosen lunches and all of the potential options. So we have pizza, sandwiches, salad, pasta and sushi. And then we have which students chose or preferred which option. So if we look at our first one, what is the experimental probability of choosing pizza, sorry. So again, experimental probability is going to be our actual outcomes against the number of trials. So how many people chose pizza? So our experimental probability of pizza is going to be equal to, well, 15 students chose it out of a possible 40 different trials. Okay? If we look at B, we can get what is the experimental probability of a student choosing sushi? Okay, well, how many students chose sushi? No one did. 0 out of 40, so the probability is just 0. Alright, let's look at C. Does the probability of 0 mean students dislike sushi? We can't say whether or not they like it, we can only say that they didn't choose it. So the answer is no. We can only say they didn't choose it. Alright, if we look at D, we have, if this survey was repeated with 400 students, would the probabilities likely change? Why or why not? So if we expanded the potential students' preferences to a group 10 times larger, we would expect preferences to change quite dramatically. A group of 40 students will not be representative of an entire school, nor an entire year group. So yes, we would expect there to be changes. A larger group will reflect different preferences. Okay, so the larger group we get, the more likely it is and that we will be able to accurately predict what the favorite lunches are for the students and what the least favorite ones are. Alright, here's one for you guys to practice, so just pause the video, give it a go, and then I'll solve it. Alright, let's get started. So a PE teacher has surveyed 50 students about their favorite sport. 20 students prefer soccer, 15 students prefer basketball, 10 students prefer netball, 5 students prefer cricket, and no students like hockey. Or in this case, no students view hockey as their favorite sport. So let's look at our first question. What is the experimental probability of a student choosing basketball? So the experimental probability of basketball . Right, so again, experimental probability is going to be the number of times a certain thing happened divided by the number of trials. So for this one, we have seen that there are actually 15 students who think this is their favorite sport, and there are a total of 50 students or 50 trials. And that simplifies down to being 3 out of a possible 10. Alright, so let's do B. So for B, we have what is the experimental probability of a student choosing hockey. So let's look at hockey. So the experimental probability of hockey is going to be 0 out of 50. Alright, so ultimately no one chose hockey as their favorite sport, so the probability of anyone in this group choosing it has been 0. Now C, does this result mean no students ever play hockey? It says nothing about whether they play it, just whether it's their favorite sport or not. So we can't say that, we can say no, we can only say what their favorite sport is. Alright, let's look at D. Would you expect the same results if the survey were done in a different school? If the survey was done in a different school, we would not expect exactly the same results. It might be similar if they're in the same type of area and the same type of sporting preferences, but it might not be. So we wouldn't expect the same results because a different school maybe have different options or interests. Alright, and we're done. So hopefully that video was helpful, and I will see you in the next one.